This video might just be an atheist's worst nightmare. Scientists have uncovered what seems like the mind of God, and the evidence presented is almost undeniable. You're about to witness how the invisible intertwines with the visible. The concept of as above, so below will gain profound clarity after watching this. All I ask is for your patience and to stay with us until the end, as everything will gradually come together and make complete sense. However, I must warn you, this video may transform you into a believer in God, so if you're not open to changing your beliefs, you might want to stop watching now. Just kidding, let's get started.
What if there were a code embedded in numbers like 1, 2, 3, 4? What if there was a secret code embedded in them that we finally got around to discovering? What would that imply? What if there was a message inside numbers? What would that imply? It would tell us something about the intelligence of the person who made numbers. And as a matter of fact, there is a secret code built into numbers that was discovered in the 1980s. It's been there since
can belong to certain groups based on rules, like being even or odd. The Mandelbrot Set is a group too, but it's special because it involves complex numbers. These aren't your everyday numbers. They're made up of two parts, one real and one imaginary, like a blend of the tangible and the fantastical. The Mandelbrot Set is defined using a special number, c, and a process that involves another number, z or z, which starts at 0. The formula used is zn plus 1 is equal to zn to the power of 2 plus c. This means you take your current value of z, zn, square it, add c, and this becomes your new z, zn plus 1. The key question is whether z remains small or becomes very large. If z stays within certain limits and doesn't increase indefinitely, then c is a part of the Mandelbrot set. If z keeps growing bigger and bigger, then c is not a part of the set. For example, if we choose c as 1, the formula becomes zn plus 1 is equal to zn to the power of 2 plus 1. Starting from z is equal to 0, we see that z rapidly increases in size, indicating that 1 is not a part of the Mandelbrot set. However, if we choose c as -1, we find a pattern where z fluctuates but remains small, indicating that -1 is a part of the Mandelbrot set. The Mandelbrot set includes not only real numbers, but also complex and imaginary numbers. Imaginary numbers results in a negative number when squared, symbolized by I. We plot these numbers on a plane, with the x-axis representing the real part, and the y-axis the imaginary part. I've kept this explanation as brief as possible, but now let's turn our attention back to Dr. Jason Lisle, who will guide us further into the pattern of this formula. It's an exploration of intelligence itself.
And so what we can do is we can have the computer check all these different points, and we'll see if there's a pattern to the Mandelbrot set. And so we'll take the points that belong to the Mandelbrot set, and we'll color those black. That's arbitrary. That's the way Benoit Mandelbrot did it, and we follow his example. And you have the computer check more points, and you find that all those points right there belong to the Mandelbrot set. When you run it through that formula, z stays small. And then the points that do not belong, we'll color those red, or some other color, it doesn't really matter. And so we already checked the point 1. We found that the number 1 does not belong to the Mandelbrot set, so it gets colored red. And had we checked these other points, we would find that they do not belong. And so you see, as you plot more and more of these points, a pattern starts to emerge. What's it going to look like? Well, you have the computer run through thousands and thousands of points. You have the computer check each one of those numbers, and a pattern emerges, and the pattern looks like this. It's really interesting and unexpected. Nobody was expecting that when you made a map of the Mandelbrot set, it would look like that.
Awesome, right? This is just the beginning. In a minute, it will all start making sense, and if you stay with me till the end, I promise you'll begin to see God in everything. So, let's move forward and let Dr. Jason Lisle show us just how deep this pattern can go. You're going to be amazed.
The main shape that looks kind of like a heart, that's called a cardioid. And a cardioid is what happens when you take a circle and you take your pencil on it and roll it around another circle of equal size. The shape you'll get is a cardioid. And then on the left side over there, you got this kind of spike that goes out. And you see there's this little bump on the end of the spike. So let's take a look and see what that looks like. So we'll zoom in on it. And that little bump, turns out, it looks like the entire Mandelbrot set. It's a mini Mandelbrot set. And it's almost identical to the parent, except it's got extra spikes growing off of it. But the basic shape's the same. It's got the cardioid and the circles. And, it has a little spike growing off of it, too, with a little bump. What could that be? Well, let's zoom in on that. And, interesting. Absolutely fat, and it's got extra spikes growing off of it. And that's got a little bud. How about that? Now, of course, you could do that literally forever. And there's an infinite number of baby versions built into the Mandelbrot set on smaller and smaller scales. Fascinating. Absolutely fascinating. And take a look at how small this is compared to the original when we zoom back out here. Look at how tiny it is. Isn't that remarkable? Who would have expected that little formula, z squared plus c, when you run numbers through it and you find out which ones belong, you get that.
A pattern that keeps repeating itself in smaller and smaller forms is known as a fractal. The Mandelbrot set is a famous example of such a fractal, but it's not the only one. Within the Mandelbrot set itself, there are numerous fractal patterns. Imagine zooming into one of the set's delicate tendril-like features. You might expect that eventually, the pattern will simplify or stop, but it doesn't. It keeps winding and curving, infinitely intricate. This endless complexity can be quite mesmerizing to observe, offering a glimpse into what seems like an infinite process. The Mandelbrot set provides a window into understanding infinity, hinting at the vastness of God's mind. Unlike us, who can only process a limited amount of information at a time, the concept of the Mandelbrot set suggests a mind that is truly infinite, capable of infinite complexity and thought. This dive into the Mandelbrot set's fractals is more than just a visual experience. It's a journey through a universe of mathematical wonder, a glimpse into the mind of God. The deeper we go, the more the fractals reveal, unfolding like layers of an endless puzzle. Each zoom brings us closer to the heart of mathematical infinity, showcasing the breathtaking beauty and boundless creativity inherent in God's design. This exploration is not just about observing patterns, it's about witnessing the dance of mathematics as a reflection of the mind of God.
All that, just a map of what numbers belong to that little formula when you run them through that algorithm. Isn't that fascinating? So then it occurred to me, well, is there something special about that formula? I mean, did we just happen to stumble upon to an amazing formula? What happens if we change it? What happens if we go z cubed plus c? Well, I ran the computer code through that, and it turns out you get a different shape. And very similar in some respects, but different in others. The shape here, the main shape, is called a nephroid. A nephroid is what happens when you take a circle half the size of another and you roll it around, then you get that shape. And you can see it's a perfect nephroid. Really amazing. You can also plot the intermediate powers if you want to. What z to the 2.1, z to the 2.2, and so on. And when you do that, you can see how the shape gradually changes from one end to the other, which is kind of interesting. And so you can kind of compare the two shapes.
What does the beauty and complexity in fractals signify? Fractals are undeniably beautiful and intricate, but what is the source of this beauty? An intriguing aspect of fractals is that their complexity increases as you zoom in, rather than decreasing, presenting ever smaller versions of the whole. Is the beauty of fractals due to the color schemes chosen by humans? While the colors, which are arbitrary except for black, typically assigned to the fractal itself, do enhance their appearance, even in grayscale, fractals maintain their appeal. The beauty lies not in the colors, but in the shapes themselves, Colors might enhance the fractals like salt enhances food flavor, but they don't create the beauty. The inherent shapes in fractals, independent of human choice, hold a natural attraction. Did computers create this beauty? While computers have made it easier to plot and visualize fractals, they are not the creators of this beauty. The first points of fractals can be plotted manually, although it's a tedious process. Computers have simply made it quicker to reveal what has always been there. The beauty existed before technology made it visible. Did Benoit Mandelbrot, the individual who formulated the mathematical equation for the Mandelbrot set, create its beauty and complexity? Not quite. He, like everyone else, was surprised by the intricate patterns that emerged. The discovery of the Mandelbrot set contradicted the initial assumption that it might be a computational artifact. It was a real mathematical discovery, not a human invention. Humans are capable of uncovering complex patterns, but creating something infinitely complex is beyond human capacity. The beauty in fractals is inherent in mathematics. It's an element that has always been present, but it was only with the technological advancements of the 1980s that humans could fully appreciate it. Mathematics is the study of relationships between numbers and the rules governing how they interact. Numbers themselves are abstract concepts representing quantity. For instance, the number 3 doesn't exist physically. It's a concept representing a quantity, separate from any physical objects it might be counting. Numbers are abstract and exist in the mind, not in the physical world. You can't touch or see a number in a literal sense. For example, the numeral 3 is just a symbol representing the concept of 3, not the number itself. If you erase it, you haven't destroyed the number 3, you've simply removed the representation of it. Numerals are to numbers what words are to ideas, representations, not the things themselves. So, where do the laws of mathematics come from? This question leads back to the origins of these concepts. Secular explanations like evolution don't apply to mathematical laws. Numbers and mathematical truths are constant, they don't evolve. The idea that humans created these laws is also implausible because if that were true, we could arbitrarily decide that 2 plus 2 equals 5. However, such a notion conflicts with reality. Mathematical laws were discovered, not created. For instance, the Pythagorean theorem was true long before Pythagoras discovered it. Similarly, the planets obeyed mathematical laws in their orbits before humans observed and named those laws. Now, this is the moment when everything will start making sense and everything will come together. What you're about to hear might just change your perspective forever, and the images that follow are set to show you God in everything.
Laws of mathematics are the way God thinks about numbers. And that makes sense of the laws of math and their properties, because laws of math are conceptual, they exist in a mind, they are universal, meaning they apply everywhere, they're invariant, meaning they don't change with time, and they're exceptionless. It's not like 2 plus 2 equals 4 most of the time, but every now and then it equals 7. They're exceptionless, right? And if you think about it, all those characteristics make sense in the Christian worldview, where mathematics is a reflection of the way God thinks about numbers. Laws of mathematics would have to be conceptual because God's thoughts are conceptual. That makes sense. Laws of mathematics are universal. They apply everywhere because God is omnipresent. Right? Laws of mathematics are invariant because God doesn't change with time. God's beyond time and made time. Laws of mathematics are exceptionless because God is sovereign. There's no aspect of creation that is out of his control. But if you think about it, none of those properties of laws of mathematics would make sense in a secular or naturalistic worldview. Or how could you even know? I mean, somebody might suppose, well, I think laws of math are universal, but how could you possibly know that? Everybody assumes it. I guarantee you, all astronomers, at least all the ones I've ever met in my career, all believe that mathematics works the same way in the Andromeda Galaxy as it works here on Earth. And you couldn't know anything about Andromeda Galaxy if you didn't assume that. You assume the laws of physics are the same there. You assume the laws of mathematics are the same there. How do they know that? Have they been there? Of course not. It's in the Christian worldview that we would say, hey, God's sovereign over the entire universe. He's omnipresent. Of course they're going to work the same way there as they work here. All mathematicians assume that laws of mathematics are the same tomorrow as they were yesterday. That makes sense in the Christian worldview, and yet it makes no sense in a secular worldview why there should even be laws of mathematics, let alone why they do not change with time. Or how could you possibly know that? How can you know anything about a future you've never experienced from a secular worldview? They'll try and turn it back. Well, how do you know the future? Because I know God, and God is beyond time. And He's told me some things about the future. So you see, all of the characteristics of laws of mathematics make sense in light of the fact that mathematics stems from the mind of God. The naturalist has a dilemma, however, because laws of mathematics are conceptual. They exist in the mind. We know that. Something's a concept that exists in the mind. And so 2 + 2 = 4, that's a concept. And there are other mathematical truths you could think of. They exist in the mind. But they also existed before people, right? Because again, the planets orbited before people and they obeyed mathematical laws. It's not like the planets were just chaotic before human beings, right? Came around and created math. So that you see, the naturalist has a dilemma, because on the one hand, he knows that mathematics requires a mind, but on the other hand, he knows that mathematics exists before human minds. But the naturalist doesn't have minds before human minds, you see. I mean, animals they can't really do math. So he's got a problem. But the Christian can make sense of this, because we have a mind before human minds, and that is the mind of God. And the mind of God not only makes sense of laws of mathematics, but their properties as well. Their universal, invariant nature.
Now, let's take a look at those images I mentioned earlier. Here, you can witness how the invisible becomes visible. This is where the concept of as above, so below truly comes into play. This is the mind of God.
So perfect fractals repeat infinitely and are only found in the conceptual world of mathematics. Nonetheless, the physical world contains proximate fractals, things that they go so many steps and then eventually they break down into atoms, and atoms are not fractal. So here's my question then. Why do fractals occur both in math, which exists in the mind, it's conceptual, and in the physical world, which is made up of atoms and does not exist in your mind? Right? I mean, you have this shape, that's a multibrot. That exists only in the conceptual world of mathematics. We can plot it, but you could never touch that thing because it's not physical. It's not made up of atoms. But that one is, and they look remarkably similar. This particular shape here is part of the Mandelbrot set. Looks like a bolt of lightning, but it's not made of atoms. This one is. How is it that conceptual things that exist only in the mind also occur in the physical universe? This particular shape, that might look like a plant. That's actually a mathematical graph called a Barnsley fern. And a Barnsley fern is such that each leaflet is the entire shape. Let me show you. Isn't that interesting? Let's do it again just because it's cool. See, the entire shape, each leaflet is the entire shape. Fascinating. You can't touch that though. It doesn't exist in the physical world, but that does. It's very similar. This stuff right here, that's a mathematical graph. That doesn't exist in the physical world, but that grows on your windows. This particular mathematical shape, cones on cones, it does not exist in the physical world, whereas this, unfortunately, does. This particular shape, that's part of the Mandelbrot set. It's a double spiral. You can't see that in a telescope because it's not made of atoms. It doesn't exist physically in the universe, but that one you can see it in a small telescope. The Whirlpool Galaxy, not too far off from the Big Dipper. So how is it that math, which is conceptual, you find these shapes, and then in nature, which is physical, you find the same kinds of shapes? Why is that? Now, one answer to this, and a skeptic might say this, is, well, the physical universe obeys mathematical laws. So it stands to reason if something can occur in math, it can occur in the physical world because the physical world obeys math. Okay, I'll grant that. But then I'm going to have to ask, why does the physical universe obey mathematical laws? And that is a stumper, if you're not a Christian. If you're not a Christian. In the Christian worldview, I can make sense of why the physical universe obeys math. Because the physical universe is upheld by the mind of God, and God thinks mathematically. So it stands to reason the physical universe will obey mathematical laws, because God upholds all things by the word of his power, the Bible says, and in him all things consist or hold together. God thinks mathematically, and therefore the way he upholds the universe will be mathematical. It's inevitable.
So, at the end of his presentation, Dr. Jason Lisle discusses a fundamental question. Why does our physical universe follow the rules of mathematics, a concept that exists in the mind? This question challenges the secular worldview, which struggles to explain why mathematics, being abstract and conceptual, applies so perfectly to the physical, tangible world. Dr. Eugene Wigner, a Nobel Prize-winning physicist, delves into this puzzle in his article, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. He finds it perplexing and almost miraculous that our universe conforms so neatly to mathematical laws and that humans have the ability to uncover these laws. From a secular perspective, there's no clear answer as to why the universe adheres to these mathematical rules. In contrast, the Christian worldview offers a different explanation. It suggests that the beauty and complexity inherent in numbers, abstract concepts of quantity, reflect God's thinking. These numbers existed before humans, implying that a conscious mind was present before humanity. This aligns with the Christian belief in an omnipresent, unchanging God, the source of all abstract thought. The physical world, including its approximate fractals and the universe's obedience to mathematical laws, are seen as being controlled by God's mind. This perspective believes that human capacity for science and understanding the intricate patterns of creation comes from God sharing some of His thoughts with us. This divine revelation is most explicitly communicated in God's Word and is also reflected in the moral laws written in human hearts. In conclusion, I want to express gratitude to Dr. Jason Lisle for bringing our attention to the profound connection between the universe's adherence to mathematical laws and the existence of a higher power. His insights encourage us to ponder deeply about the world we live in and the principles that govern it. By illustrating how mathematics, an abstract and conceptual realm, align so seamlessly with the physical universe, Dr. Lisle opens a window to a perspective where science and faith intersect. This presentation may serve as a bridge for many, offering a mathematical approach to understanding the divine. It suggests a universe where God is omnipresent, omniscient, and intricately involved in the fabric of creation. The harmony between abstract mathematical concepts and the physical world could be seen as evidence of a grand design, a thoughtful orchestration that transcends mere coincidence. It's a perspective that doesn't just appeal to emotion or belief, but also engages the intellect and invites contemplation. I hope this video has brought you closer to a sense of awe and possibly closer to God, presenting a unique viewpoint where the precision of mathematics reflects the omnipresent and omniscient nature of a higher being. It's a journey that intertwines the rigor of scientific understanding with the depth of spiritual insight. Whether this leads you to a renewed belief in God, or simply offers a new way to appreciate the complexity of our universe, the intersection of mathematics and divinity presented here is undoubtedly thought-provoking.